recording. All right, well, go ahead and give me an attendance note. Let me know you're here. All right, so any questions?
What was different about test 3?
Oh, I don't know. So test 3 is a lot of punctuation exercise. So let me give you an example. So let's talk about debugging. Alright, so here's a version of PA5. It looks like it works pretty well. And it works fine on here, and it works fine on here, and it works fine on here, but when I do this, it does this business. And I think a few people saw things like this, where test 3 is like breaking things. So a lot of the purpose of this assignment was to get good at debugging, right? To get good at analyzing code, breaking things out, working with things one at a time, breaking problems down, finding test cases, all of these skills related to dealing with bugs. So I try to run my M2 script and it says there's an error at line 37. So what do we do? So I'll do 37G. So it doesn't like this statement right here, right? Well, what am I doing? I'm doing, $ curly bracket count. Count is an associative array. I declared that up here. And I'm using $ phrase. I put it inside quotation marks. But something is going wrong with this statement, right? You've got the exact test case that you need, right? I can run it on test3.in. So let's figure out what's going on in this statement. Why doesn't it like this? Well, probably the first thing to think about is, let's take a look at what $ phrase is. And I'm going to put it inside angle brackets, and I'm going to put it inside quotation marks. Quotation marks will almost never hurt you. They will often help you, right? They will prevent certain things from being interpreted. So I'm going to put them in quotation marks, and I'm going to put angle brackets so that if there's spaces, at the end of phrase and so on, I can see what's going on. So this is just a debug statement. So if I run this and I get to the line where it's about to throw up, I can see my phrase is empty. And so now let's go back in and let's take a look at this line. It's line 38 now. And if phrase is empty, this is count bracket bracket, because $ phrase evaluates to an empty string. So now maybe we make a test on the command line. So it's an associative array. I can do that. What if I try to do this? What if I try to do this? That's where I get my bad array subscript error. So it doesn't like when that phrase is empty. And so what can we do? We can put an if statement in here. We can say if the phrase is empty, right? And since we're inside a loop, we can use a continue statement. And I'm going to get rid of this debug. And suddenly it starts to work. So when you get messages like this, right, that's when you got to dig into the code and start taking it apart. So yeah, there is no GDB for bash. The one trick that sometimes works is you can put a -x and it will, or maybe a lowercase x. Right, and it will give me some information while it's processing. Sometimes this is information overload, right? But if we get rid of that, right, we can see right here that you know, before it gives me this error message, phrase is equal to, and it's just showing me blank. So sometimes putting that -x at the end of the shebang will help. And X is just an option for bash that says, you know, show me what's going on as we execute. So when you change the values of expressions, or when you're about to run a statement, I think it also shows you indent level, and so on and so forth. So post-mortem on PA5. So most people got this to work in the end, which is great. And if you used 2 or fewer slip days, you should already have grades posted in Canvas. If you use 3 or 4 slip days, those will get graded later this week. And we'll go through the code for PA5 in detail tomorrow after the last slip day has passed. But what's the sort of general takeaway from PA5, right? This was, in the end, not necessarily a long program, right? Some people got it down to 1 line. Most people got it down to 20 or 30 lines if you take away comments and spaces. It's not particularly a lot of statements. It's not a lot of complex looping. But there are issues involved in making this work, right? And the assignment prompt and the way we've talked about this in class is not just, you know, random stuff that I write and talk about, right? I'm usually trying to give you an idea how to do the project in a way that will make it, you know, as useful to your learning as possible. And so we had this sort of general flow of, like, you know, read a line, cleanse it, parse it, and then for each phrase, tally. And doing this in a loop until there's no more input, and then output the results. And we talked about 2 different ways to do this reading 1 line at a time in a loop. We could do a while read line, or we could check $? Right? But this is, you know, read a line, cleanse it, parse it, and then go through each phrase in the parse line and tally it. This is just a read statement. This is a bunch of, you know, sed and tr and, you know, all of these manipulations. And then this is a for in statement, and this is the associative array. And then this is another for in. And it seems like a lot of people completely skip the idea of reading a line at a time and just try to read the entire input into a single variable. And that will work, but it can take a long time, and it will eventually blow up. If you tried to read, a billion lines of text, that will blow up on you. If you read a line at a time and you're tallying, right, you can do that with a billion lines of input and not run into a memory problem. But I want you to know how to iterate on input in bash, and you're going to see that on the exam, right? You're going to have a question where you need to do what I was asking you to do in PA5, which is read a line of input, do some processing, detect when end of file occurs. So you definitely want to know how to do this, and if you didn't do that in PA5, if you did a workaround instead, right, make sure you understand this business of like while read line or using $?? And if your script began with something like, this, a TR, and you pipe it into sed and so on and so forth. Well, when I say TR, right, if I don't pipe something into it, it reads from standard in. And if I feed a file into here, right, then TR is consuming that entire file, and it's going to read, all 5,000 lines of test 4 before this TR statement finishes. And if I'm saving this in a variable, then I'm ingesting all of that stuff and saving it into one variable in bash. And then when I start trying to process that, that's where some of these long execution times kick in. So what did I see? Yeah, so the ODPs are designed to help with the programming assignments. And I didn't have those for PA5. So that probably would have helped. What I wanted people to do was to kind of do what the ODPs do on their own. In other words, when you're trying to do something like this and it's not working, come into the command line and, try this. Okay, that works fine, but I want to save that in a variable. How am I going to do that? Well, I'm going to try something like, line equals back quote this thing. And then if I echo $line, oh, $line is now, this is a test, right? If you don't know how to do this, right, that might be something that an ODP would have. But because we're doing bash, right, we can do these kinds of statements in isolation. We don't need a whole program to use these. And if our goal is, let's convert our input to uppercase, we can just exercise our knowledge of the TR program, our knowledge of back quotes and assignment statements and so on and so forth. And the first time I do this, right, and I get an error, I know I'm doing something wrong. There's some problem with this assignment statement, right? And I know exactly where it is. It's something going on right here. I don't have to look through my whole script. I don't have to run through all kinds of test cases, right? I've got a problem right here. And that's where, you try different things. You go back to the notes. Maybe you Google, but hopefully you come to office and ask. And once you figure out, oh, I can't have that space there, right? If you found that on your own, you're not going to forget it, right? It's going to really sink in. It's the hard-won battles that sort of make the most impact memory-wise. And then, you're going to write things like this and go on to the next bug.
I couldn't quite figure out. I think you went over this in class, but it kind of sailed over my head. But these are multiple regular expressions in this sed command.
So what I suggested for PA5 was just something like this. Do command 1, pipe it into sed, blah, pipe it into sed, blah, pipe it into sed, blah, right? And that's the easiest way to, you know, do a bunch of changes. But you can also do a sed dash f name of a program, and then this can contain each of these commands, one per line, and it will do those in succession. But then you got to have a separate program file, right? You've got to make sure it's in your Git repository and all this kind of stuff. And when you're reading your script, you've got to you know, leave your script and look at this program file and see what's in there and so on. And this is definitely how I would develop it, right? When I was trying to work out the details of the regular expressions and so on. And then maybe if you were bundling this for some other project, right, and it was okay, you could throw all of that into a separate file. But I would just go ahead and just, you know, bang, 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 pipe them into each other. And
That's what I wound up doing. It just.
Yeah, I think it's a good approach. But yeah, you can do it like this too. And you know, there's lots of stylistic options. So you can do this as one big long expression, or you can do, you know, read line, and you can say line equals echo $line, pipe into sed blah, and then you can do line equals back quote echo $line, pipe into sed blah, and so on. And so I'm taking my line that I read, I'm echoing it and sending that to standard in of sed, and then sed is processing that, right? And the result of this, sed will output to standard out by default. Since it's in back quotes, the result of that will get stored back into line. And then I put new version of line into this version of sed, and I take the output and save it into line. And that's another way to do it. Another way to do it is to, you know, read line 1, echo line 1, save that as line 2, echo line 2, save that as line 3. For debugging, this is really useful because, you know, you can print out each of these values of line, and that can help you figure out if something's going wrong. You know, when I got to line 5, it suddenly became blank for some reason. So that can help with debugging. And if you break it up into statements like this, either with one variable or multiple variables, right, you can throw echo statements in here. And you can watch as you're processing your input line, as you're changing it, as you're cleansing it, you can watch what's happening at each step. And at this point, if your phrase suddenly disappears, hey, something's funny in this statement right here. And so a big part of debugging is sort of narrowing down where the problem is. And debugging is really the essential skill of programming, right? To write a program, once you have an algorithm written out, right, in your head or on paper, and if you're working in a language you're familiar with, it might take you 10 minutes to write the code, right? It might take you 10 hours to debug it. It's the process / art of taking apart the code and, well, finding a test case that fails, right? Narrowing it down to a minimum test case, and then being able to work through the code and figure out where it's doing something different from what you intended, right? That's what debugging is, basically. And that's such an essential skill. And so don't shy away from bugs, right? If something's not working, don't just delete it and try something different. And I saw lots of creative coding where people were doing lots of things with double parentheses and cat space dash and triple less than signs and things like that. And, you know, sometimes you get lucky and doing something like that fixes your problem, but the problem is not, you know, that you're not using triple less than signs or double parentheses or something like that. The problem is something about how you're interpreting what a statement is supposed to do versus what it's actually doing. And that's really, really worth figuring out, right? Because if you think things are supposed to work one way and they're working a different way, finding a totally different approach that solves your problem doesn't fix that misunderstanding. And it's those misunderstandings that you want to sort of drill down into. And the harder it is to find, the more important it is to find it. Because if it's a deep misunderstanding, then you definitely want to ferret that out. So this was probably a more challenging assignment for a lot of people than most of the previous ones. and it's a different flavor of assignment, right? Because it wasn't, you know, 500 lines of deeply nested loops and all this kind of stuff. But the main goals were, you know, being able to read input from bash one line at a time, detect end of file, being able to do, you know, sed and awk and tr and all of these regular expressions and stuff like that, and then the associative array part, which was definitely something new and different. And so that combination, yeah, that can make it super challenging. But in the end, it looks like most people were able to do this. Some people got tripped up on test 3, but by and large, most people got this working. A lot of slip days. I think people were cashing in their slip days because they had saved them. So I've still got assignments coming in. Test 3 had tabs in it. That's very possible. Yeah, test 3 does have a tab in it. And I think tabs will get treated as spaces when you do a for in loop. All right, other questions? So CSE222 is going to be all C. We're not going to do any bash in there. It's going to be all C programming, and it's going to be a lot of ODPs, which will be geared largely towards the programming assignment. So we'll definitely be returning to ODPs in 222. And I heard some people saying they missed working in C. So that will be your course to get as much C as you can stand, because that's really all we do in that course. So that'll be good for people. All right, so we'll talk more about PA5. We'll run through some sample code tomorrow. But let's switch gears. So this is our last week of classes, right? So so end of the week, probably Friday, we'll just spend, you know, for wrap up. And talking about the final and such. But I want to talk about processes in bash. And you know, we've been using processes. Every time we type a command, it's a process. But I want to go into some specific details and look at some aspects of processes. So let's see. 10:30. Go ahead and do another attendance ping. So process is, you know, it's a job, it's a stream of instructions that the CPU is executing, associated typically with a user. And, you know, there's a process running on my machine right now, and it's running the program called bash. And that particular process is sitting here, it's just printed out this number, this prompt, and it's waiting, and anything that I type, it's going to echo, and when I type an enter key, it's going to interpret what I typed. So that's a process. And if you just use the command top, you'll see all the processes running on your system, and it tells me there's 355 things running on my system right now. 3 of them are running, 279 of them are sleeping. And most of these are owned by root. Well, most of the ones up here seem to be owned by Nick. But root owns most of the processes on the system. But user Nick, that's me, owns some things like GUVC view. That's the thing that's running my camera, my document camera. So yeah, process is basically, you can think of it as a thread. There's technical meanings to those terms, but yeah, for first purposes, kind of the same thing. So I've got a screen recorder running, I've got Zoom running, I've got 2 cameras running, I've got audio running, I've got a bunch of stuff related to the fact that I have graphical, widgets on my desktop. I have some terminal programs called Console, I've got Chrome running in the background, Dropbox, right? Each of these is a process. And so, good command to know is PS. And if I just say PS, I get a really simple display which shows me processes currently running associated with my current Unix session. Right? Now there's lots of processes on the system, but when I say PS without any other switches on here, it shows me 2 lines. The first line says bash, and it has a process ID, 2532. And the second process is a command called PS. Well, that's this command right here. And it's got a process ID 23556. And this is how much CPU time the command has taken, and this is where it's running from. And that's kind of a funny thing. So it used to be that, when you had a computer, you had terminals, physical terminals, with wires connecting each terminal. Terminal's a keyboard and display. Wire connecting that terminal to the computer. And each connection point was labeled TTY0, TTY1, TTY2, and so on. And so if you saw that somebody, had a process running and it said they were on TTY7, you could find where TTY7 was plugged into the back of the computer. You could trace that wire. You could see the actual terminal from which the person had started that process. So we don't do that anymore, right? Everything's virtualized. So these are pseudo terminals, PTS. And so this is a fairly not very interesting piece of information. But this PID is a really important piece of information. So this is the process ID. And, picture yourself, you're an operating system, you're managing 200 or 300 processes, you've got 1 CPU, maybe you got a few cores. You've got to decide, what should I be doing? Should I be running this process, that process? Should I stop running that process and switch to this other process, right? You've got all this housekeeping that you need to keep track of. And all of that information is keyed off of an integer called a process ID. And yeah, this process is running bash, it's owned by Nick, it's sitting here on this keyboard and so on, but the operating system knows it as process 20532. And when I said PS, which said, hey, I want to see what the process status looks like, it created a new process to run that command. And that process was process ID 23556. So these PIDs are sort of the way that the operating system interacts with processes. And if you want to talk to the operating system and ask it to do something or tell you something about a process, you generally use the process ID. Now if I do the PS command again, I still see a process named bash with process ID 20532. That's my bash process. That hasn't changed. But guess what? The PS command, that has a different process ID. That's 23619 versus 23556. And if I do PS again, PS has a different process ID. So what's going on here is that every time I type a command, a new process is created to execute the command. While the PS command runs really quickly, it basically displays some information and then exits. And so if I say PS again, a new command is started, and that new command has a new process ID. So if I say sleep for 100 seconds, and then I come over here and I say PS, so I'm in a different terminal window, I don't see that sleep command. So by default, PS is only showing me things associated with this current session. And you notice in this new window over here, it says these are owned by PTS3. Whereas in this window, they were owned in PTS2. Let me put this in a separate spot here. But the sleep process is running somewhere. I know if I hit ctrl-C, I can cause that sleep process to stop. And now if I do a PS, I just see my bash and my PS. Alright, so let's talk about ctrl-Z. And I've told people, don't use ctrl-Z. If you want to kill something, use ctrl-C. If you say sleep and you want to change your mind, Control-C. What happens if you hit a Control-Z? It says stopped sleep 100. And now if I do a PS, hey, I've got three things out there. I've got my bash script, still 2532. I've got my PS command, which I just ran when I said PS. But I've got this other process, says it's running the command sleep. And that's process ID 24111. That's the sleep command. And when I hit Control-Z, that didn't kill that process. It stopped it, but stopping is different from killing. Right? When you stop a car, the car doesn't disappear. It just stops moving forward. That's what stopping a process does. The process is still there, but you've said don't advance any further. Just stop what you're doing. But that process is still there. And if I say PS, I still see it. And so the reason I tell people not to use Control-Z is that if you keep using Control-Z, you end up with a lot of processes that aren't running, but they haven't gone away either. They're just kind of like sitting there taking up resources. Alright, so what do you do if you hit Control-Z? There's a pair of commands, so you can say foreground or background. FG or BG. So if I say FG, it says, hey, if I've got a stopped process, unstop it. Right? So now I'm back to doing my sleep 100 command. And if I hit Control-Z again, it stops it again. And if I say FG, it brings it into the foreground again. I just ran out of my 100 seconds. Let's do 1,000. So FG says, you know, unstop this process, bring it back as if I had not hit Control-Z. BG says, hey, unstop the process, but don't bring it back into, you know, the same state it was in before. Let it run in the background. So if I say BG, it tells me, hey, this thing is running in the background now. And if I do PS, it no longer says stopped. Right? It's PS, but it's actually running. And if I had, you know, slept for 20 seconds, it would exit after 20 seconds. But I'm not sitting here in the middle of a sleep command where I can't type and it you know, is ignoring what I type. It's running, but it's not taking over my keyboard input. So normally, you know, if I'm sleeping and I type stuff, it's not paying attention to me because the sleep command is not supposed to pay attention to standard in. It's just supposed to hang out and wait for 1,000 seconds in this case. So if I Control-Z it, I can type commands, but my job is stopped. If I say BG, my job is now running, but I can still type other commands. So if you have something that takes a long time to run and you want to do other things at the same time, and you don't want to open up a new terminal session, right, you can background the thing that's taking a long time, and then still do other things. So my sleep is running right now. If I say FG, it doesn't stop it doesn't kill the program. It brings it back to where it was before I hit Control-Z. So it acts as if I had typed in this command and I had not hit Control-Z. It basically undoes the Control-Z. And so I'm back exactly where I was, and I'm in this state where it's ignoring my input because it's running the sleep command. If I do BG, it unstops the program, but it does not, it runs it in the background. Right? So if it's running in the foreground, it's listening to my keyboard input. If it's running in the background, it's not paying attention to my keyboard input, basically. So I can start another sleep 2000 and I can Control-Z that and put that in the background. Now I have two sleep statements running. So in addition to PS, the jobs command is useful when we're dealing with foreground, background. So if I say jobs, it will show me my jobs that I have running. It doesn't show me bash, it doesn't show me jobs or PS, but I've got two jobs running. One of them is sleep 1000, the other is sleep 2000. And they're both running. And there's a little plus sign next to this one. This means if I say foreground FG, it's going to bring this job into the foreground. So now I'm back to my sleep 2000. If I hit ctrl-Z, it's stopped. And if I say jobs, now I can see this job is stopped. My 1000 is still running. If it was in an infinite loop, or if I decided I just want to get rid of it, right, I can foreground it, I can hit ctrl-C, and that's always going to, almost always going to kill my job. I've still got my sleep 1000 running. I can foreground that, and I could ctrl-C to kill that. Alright, you can also foreground and background particular jobs. For example, if I want to bring job 1 into the foreground, I can say foreground %1. And the %1 says, hey, job 1, where job 1 is the one identified by the 1 inside angle brackets. And I can ctrl-Z that. Put it in the background. Alright, we can also kill jobs from the command line here. So for example, if I want to get rid of this job 2, I can say kill %2. And that says, hey, make job 2 go away. But it doesn't show me anything because a lot of times Bash will hold its tongue until you've hit enter. Because if I'm typing something, it generally doesn't want to display some information in the middle of what I'm typing. So if I hit enter again, then I'll get the message saying, hey, job 2 was terminated. This was what the command was. And now if I look, I got a single job running. So I can foreground it and ctrl-C it, or I can just say kill %1. Or I can leave it in the background and let it just run until it's finished. Or I can bring it into the foreground and let it run. If I know I've got a command that I want to run in the background, and I don't want to run it and then hit ctrl-Z and say BG, you can put an ampersand after any command and say, hey, run this job in the background. And so this command automatically starts running in the background. It's job number 1, and if I say jobs, it tells me that job is running. And so now I've got 3 jobs, and they're all hanging out in the background. Alright, PS just shows me my basic display. I can start adding switches to the PS command. So one useful switch is just PS-L, and PS-L shows me more information. Alright, so what am I seeing here? The command is listed over here, the CPU time, and sleep doesn't really take much CPU time. The terminal, TTY, teletypewriter, the terminal that's associated with this. So PTS2 is this window over here, whereas if I go to a new window, like this, right, this is PTS4. So the TTY is sort of which console window I'm in. And something about memory usage and niceness, which is the priority at which it runs, and so on. But here's our process ID. And there's also a parent process ID. So processes are created by other processes. right? That's how all processes except the ones that boot up come into existence. They're created by other processes, and we'll talk about how to do that this week. But let's take a look at this PS command. Its process ID is 26738. Its parent's process ID is 2532. Each of these sleep commands, the parent's process ID is 2532. What is process 2532? That's my bash shell. So I can see a hierarchy of processes here. I can see that, bash is this process that's running, and its process ID 2532. Well, this is bash shell is also the parent of these sleep commands and this PS command. And if I do my ps-l again, my PS has a different process ID, but the same parent process ID. So there's a hierarchy. Here it's showing me the numeric user ID instead of a name. So 1000 is the user ID for user Nick, which is me. And here's the state of the process. So bash is sleeping, my sleep commands are sleeping, my PS command is running. Why is my PS command running? Because that's what was generating this line of output, was the PS command. And in order to do that, it had to execute some statements to say, hey, what's the state of this process? And when it checked, it looked at itself and it said, oh, I'm doing stuff. And so its state is R. And there's a billion switches we can put on the PS command. So -F shows me the full command. So I can see this is sleep 1000. I can see that bash was actually /bin/bash. I can see that PS was actually ps-f, right? Whereas up here it was just showing me the main command name itself. And I can see the start time, right? When did these commands begin? Well, bash started at 10:04. That's when I opened this window. The sleep started at 10:41. The command I just typed was 10:45. If I do ps-e, that shows me information about every process on the system. And there's a lot of processes. So a useful command is ps-elf, ELF. ps-elf, make your display wider. Gives you information about every process on the system, and it gives you the full command name, tells you the CPU time, the start date and time, who owns it, the current state of the process, and all sorts of information. If you want to see everything that's going on in the system, ps-elf is a good way to do that. But sometimes you don't want that much information. Sometimes you just want to know, what is Nick doing? Right, so if I say PS, it just shows me, my processes, which are this. If I say PS-U followed by the name of a user, it'll show me what that user is doing. And now I can see that Nick is doing a bunch of stuff on the system. Running Chrome, running some cats. Let me do a FU, nothing bad there. But full listing for user Nick, and I got lots of stuff going on with Chrome. But look, there's my sleep 1000, 2000, 3000 from PTS2, and there's bash. So I'm looking at what's going on in this window over here, right? So I can see all these processes going on, and you can do this on the Linux server, and you can see what everybody on the system is doing. There's where I'm looking at the PA5 assignment in my PDF reader, and we'll find Zoom, and there's Bluetooth going to my soundbar for audio and all sorts of stuff. And this is all viewable information. But it's a useful way to study process trees. For example, all of these things, user bin, Clementine, tag reader, are owned by process 19086. And if I find 19086, that's Clementine, that's the music player. But that process created all of these helper processes that are children of 19086. So if you have your own Unix set up, you can definitely play around with this, but you can also hop on the server and see what's going on. And you know, if there's an ODP running, you can do a ps-elf, and you'll see the assess server running somewhere out there. And if there's ODPs that are queued up, ready to go later in the week, you'll see jobs that are sleeping that represent those upcoming ODPs. All right, so that's a little bit of a view of you know, how we can look at and interact with processes from Bash. So the next question is, how can we do things in Bash scripts that interact with processes? And in particular, I want to talk tomorrow about signaling processes. So how can we send messages to a process? And when you're running a command like sleep and you hit ctrl-C, ctrl-C doesn't just automatically kill the process. What it really does is it sends a signal to the process. And that signal says, hey, I would like you to stop what you're doing. And if it's a command that's amenable to that, it will exit. But sometimes it won't. For example, if you're in VI and you hit a ctrl-C, it doesn't stop VI from running. It does something different. Right? It says, hey, do :QA exclamation mark if you want to quit. Alright, so we'll talk about signals tomorrow, and then I want to start looking at how this happens in C and how processes get created. Alright, we're out of time. Go ahead and send me an attendance ping on the way out, and I will see you next time.